All right, so I'm going to attempt to solve. These were two quizzes given to my regular slots. These are combo circuits, and I think I'm going to zoom in over. Damn it! Can I zoom in over here? Can I zoom in without making stuff bigger and smaller? I don't even know. Let's go here. Okay, here we go. All right, so we're going to start with this one right here. And what I'm going to do, as I like to do, is I'm going to pull out a highlighter. You're going to hear me tapping away because it's going to be kind of a lot going on here. We'll note first of all that there is no ground. So I'm going to take the negative side of the battery, and I'm going to make everything over here have a voltage of 0 because everything that is touching a line, a wire without interruption, that all has the same voltage. Right, and then let's see, we'll do maybe red for the positive side of the battery. Okay, so this side of the battery, dadgummit. How do we do that? Can we undo that? We can't undo that. Okay, let's do this. Everything over here has the same voltage until it hits that resistor. Now notice this was a little annoying, right? Because we're using kind of a different resistor over here, a different symbol for a resistor. Whoever made this one likes boxes instead of the standard thing. Okay, we'll note that the delta V on the battery is 12 volts, so that means we went from 0 over here to 12 volts over here. All right, now between the, so we still have one more area that has a different voltage, right? So over here, everything, oh, dadgummit. Okay, so everything over here, we're going to say has a blue voltage, right? So everything that is connected via wire has the same voltage, right? So this will be V, we'll call it V2 equals, well, we don't know what that is. Okay. All right, now before we get into solving this, let's just kind of review a little bit of what's happening over here. Okay, so the current is leaving the battery, right? It's going this way. We're going to do this in gray. Okay, it's still the same current all the way through the resistor until it forks, right? Okay, now I typically call that I0. Whatever leaves the battery is I0. Okay, we'll note, that's kind of cool, like, because we know that whatever leaves the battery is also what comes into the battery. Okay, so all this has to be I0. Okay, where do we stop it? Where does it stop being I0 or, whatever you want to call it exactly? Well, it's going to stop wherever there's a fork, right? So here's the fork right here, and here's another fork right there, or a junction, right? So if we zoom in on those particular things, okay, at those points, it's going to split. Oh, well, let's do this in black. Let's undo that. Okay, so it's going to split. Some's going to go this way, going to go right through R2, and it's going to come down there. Okay, I'll go ahead and call that current I2 because it's going through resistor 2. Okay, and this current right here going this way, it's going through resistor 3. So I'm going to call that I3. Okay, we should note that I2 and I3 are going to add up to I0 because that's where it comes from, right? If you look at this, well, whatever goes in there, which is I0, has to equal what's leaving it, which is I2 plus I3, right? Or by the same token, I could do it here, and I could say, oh, well, whatever goes into that is I2 and I3, and whatever leaves that is I0, right? So anyway, so those things might be helpful for us. All right. Now, with all that in mind, what I want to know is I want to look for, do we have anything in series, and do we have anything in parallel? Okay. And so for series, what we're looking for are there any resistors such that everything that flows into one flows directly into the next one? Okay, so everything that flows into R1 has a current of I0, but then it splits, right? So it's not all going into R2, it's not all going to R3, so that's not in series, right? And R2 and R3 are not in series because, well, I mean, they don't even have the same currents at all, so nothing's in series. Okay, what about in parallel? We're looking for things where they have the same voltage drop across them, right? So R2 has a drop that's going from V1 here to V2 here, right? Nothing else is going from red to blue, so nothing is in parallel with it. And then for R2 and R3, we see that they're both going from blue to gray or black or whatever, and this one's going from blue to gray or black or whatever, right? So they've got the same delta V. So R2 and R3 are in parallel. Dadgummit, I did this on the other one too. I made that a B right off the bat. I don't know why I made it a B. Okay, so we'll change that to R3. So these are in parallel. So first thing I'm going to do is I'm going to combine those two, okay? So let's go down here, and what I'm going to do, I'm going to leave this kind of on the screen, and I'm going to redraw this circuit relatively quickly, okay, because I don't want to spend all day on this, okay, and maybe I got a little excited there. Okay, so we're going to put this resistor in here, and what I'm going to do is I'm going to go here, I'm going to put another resistor right here, and then we're going to go this way, and we're going to go all the way around, okay? So this is going to be called, I'm going to call this R23, and this is going to be R1. Okay, R1 we know is 2 ohms. Okay, R23 is unknown. All right, now because we're here, I'm going to go ahead and I'm going to, here's my battery, 12 volts. Okay, so let me go ahead and do my voltages again because I think it's like such a useful thing to do. Okay, so here we go. So all of this still has a voltage of 12. Okay, so if I go here, so this is a V1 equals 12 volts. Okay, I know that everything over here, V0 is 0. Okay, and how far does that extend? Well, that's all of this. And all of that is a voltage of V0. Okay, and then I'll notice I still have that blue region in between the two resistors. The nice thing about doing parallel is that the voltages don't change, right? So this is going to be, well, I guess we wanted this in blue, didn't we? V2 equals, now we don't know what that is, right? Okay, so let's see. All right, so I need to get what R23 is, so I noted that they were in parallel, so let's go ahead and use the parallel formula. I don't want to go on that side, so let's go on this side. So we'll say R2, dang, gummit, it's a pencil. Okay, we'll use a pen. Okay, so let's see here. So R23 equals 1 over, what was R2? 3 and 6. Okay, so 1 over 3 ohms plus 1 over 6 ohms. Okay, -1, that's the thing that people are going to forget. Okay, why? No particular good reason. It's just a nice careless error to make. Okay, so the pigs thing here to check that our answer makes sense. This 2 has to be less than the smallest of those. Okay, so we got a 2 ohms. Okay, so this is going to be a 2 ohms. Okay, cool. All right, now let's see. We're staring at this sucker. Let's go ahead and do the current. Just because we're here, we might as well. Okay, so let's remember that the current's leaving this battery. Oh, we've gotten rid of all the forks. So there's nowhere else for the current to go, so it's got to go make the full loop. So here's my I0. Sweet. All right, now we'll note we're looking for series or parallel. We'll note that everything that flowed into R1 is going to flow into R2. So we're feeling pretty good about that. So they're in series. So go ahead and we'll redraw this one more time. Okay, so delta V equals 12 volts. Okay, so we're going to go this way. And then we're going to create equivalent resistor. Okay, this could be R123. I'm going to call it REQ. Okay, because it represents the equivalent resistance of the entire circuit. Okay, let's see, let's do voltages again. So note everything over here is red. Okay, and everything over there has a voltage of V1 equals 12 volts. Okay, everything over here has a voltage of 0. Okay, so we'll go V0 equals 0. Okay, right. All right, so now we're going to get the I0. Okay, the current is leaving here. It's going all the way around here, and it's coming all the way back around. There's nowhere else for it to go. So this will be I0. Okay, so now we need to know the REQ. I'm not even going to show the work here. We just add these two up, right, because they're in series. So it's pretty easy. So this is 4 ohms. All right, so let's go ahead and solve this. Solve this guy. Okay, so let's do it. So let's see. What do we want? Well, we know the voltage. We know the resistance. So the only thing we need to know is I0. So I0 equals delta V bat divided by REQ. Okay, so I0 equals 12 volts divided by 4 ohms. So I0 equals 3 amps. Sweet. All right, so now that we've solved this guy, okay, solved, check. Okay, now we're going to use that information and we're going to solve the one above it. Okay, so let's solve this sucker. I think I'm going to erase this calculation over here because it's kind of in my way. Let's see if it'll let me do that relatively easy. It looks like it will. All right, so let's see. Let's go back over there. Come on. Okay, what do we need? Well, let's see. It looks like I know the current everywhere because I solved for I naught a second ago. It was 3 amps. I know my resistance is. Okay, it's just this voltage right here is the only thing I don't know. So what's cool about that is if you have currents, then you can get delta V's, right? So let's do delta V on R1, and then we'll do delta V on R2. Oh, they're going to be the same. But anyway, delta V on R1 equals I1 R1. So delta V1 equals, let's see, all of this I's. This was all 3 amps, right? 3 amps times R1, which was 2 ohms. So delta V1 is 6 volts. Okay. R23 has the exact same resistance and the exact same current. I'll go ahead and do the equation officially. Delta V23 equals I23 R23. Okay, so delta V23 equals, it's the same current because they're in series, 2 ohms, and then delta V23 equals 6 volts. Okay, so in other words, what this means, this delta V1 means I had 12 volts, and then I got here, right? And now I'm going to decrease by 6 as I go through that resistor, right? So that's going to leave me with 6 volts here, at which point I'm going to go from here to here, right? And I'm going to change by another 6 volts, okay, which is going to get me down to V naught of 0, right? So we feel pretty good about this, so I'm going to go ahead and say that this one is solved, right? So we're pretty good here. Check, check. All right, so now we're going to go back up here, and let's see, what else do we need? Let's see, I know this is 6 volts. Let me clean this up just a little bit. It's getting a little bit messy in there. Can we erase some of this stuff? Oh, look at that, we can. That's so lovely. All right, now, so the only things I don't know in this whole thing now are those currents, right? I don't know I don't know I2 and I don't know I3, right? So let's go ahead and get those. Okay, so if you're looking for currents and you have voltage drops, now remember the voltage drop is going from 6 down to 0, so the delta V is 6, okay? So for this guy, for the number 2 here, let's see here, I2 equals delta V2 on R2. And I can do the same thing for number 3 here, right? I3 equals delta V3 over R3. Okay, so let's see here. I2 equals delta V2, oh, right, delta 6 volts, right? Because it's going from 6 down to 0. Okay, R2 is 3 ohms. I3 has the same voltage drop, okay, with 6 ohms of resistance. So I2 equals 2 amps, I3 equals 1 amp. Okay, now what's the check to see that we did this right? Well, we know that whatever was flowing in through here, which was 3 amps, okay, it's going to split, right? And so whatever the split is, we're going to have just as many total, right? So these two add up to 3 amps. So we have to feel pretty good about that. Okay, so what's our solution going to look like? What are answers at the end of the day? Okay, well, we would have delta V1, delta V2, delta V3, I1, I2, and I3. Okay, and we would just write all of these down. Okay, so the delta V1, that's the difference in the voltage from here to there, right? And it went from 12 down to 0, so that's 6 volts. Okay, delta V2, well, that's the voltage change from here to there across resistor 2, right? And that went from 6 down to 0. Right, so that's going to be a 6 volts. Okay, delta V3 is going from here to here. That's the exact same because they're in parallel. All right, okay. And then I1, okay, well, that's right here. That's 3 amps. Then I2 is how much that went this way. Okay, and that's going to be, what was the answer there? Oh, 2 amps. Okay, and I3 is 1 amp. Okay, and those are your answers. All right, so that's problem 1. Okay, 14 minutes. Okay, so now let's go on to number 2. All right, let's see here. All right, so this has more traditional symbols here. for whatever, I'll just put the answer key over here, I guess. I didn't do this on the other one, but let's see here. So I'll call this delta V 2.5, delta V 10, delta V 50. Okay, and I'm also going to want to know I 2.5, I 10, and I 50 equals. Okay, so that's what we're looking for, all of that stuff. All right, so let's go down here and look at this. What do we have? What's going on here? All right, so the first thing we want to do is we want to pull out a highlighter, and we want to just start highlighting stuff. All right, here's our highlighter. Let's do this kind of blackish, grayish color for down here. All right, looks kind of weird on that green, doesn't it? Anyway, it's all down here. All of this has the same voltage. Okay, so I'll go ahead and I'm going to call that V0. Why? Because it's on the negative side of the battery. Okay, all right, sweet. Let's do the red here. So dadgummit, can we get a highlighter? Can I get a highlight? Dadgummit. Okay, come on. Delete that. Thank you. Okay, we got red highlighter. It looks more like crayon on this one. Okay, everything that's touching with the wire has the same voltage. Okay, it doesn't matter if it splits. All of this is the same voltage down till it hits a resistor or battery. Okay, so there you go. Okay, and we'll note that the battery is delta V. Dadgummit. Okay, delta. Dadgummit. Okay, delta. Dadgummit. There's a lot of dadgummits going around these worlds here. Okay, delta V equals 10. Okay, so we were at 0 on this side. So when we get to the high side, we're going to be at voltage 1 equals 10 volts. Okay, sweet. All right. Oh, we forgot a voltage, didn't we? We forgot one. I apologize. How come you didn't call me out? Okay, we forgot this little voltage right in here, in between these two. Okay, I'll go ahead and call that, what's that, V2. Okay, we don't know what that is yet. All right, so we got all of our voltages that we're going to get. I think that's it. Okay, so let's start talking about currents. And we're going to note that the current is, let's get gray. Okay, so the current's leaving the battery. Okay, remember it's going to stay the same until it splits. Okay, so it's going to go right there. Okay, so that's going to be I naught. Okay, I'll note that whatever leaves the battery has to come back into the battery. So I know that it's all going to be I naught. Okay, all the way back until it splits, right? So here's my I naught again. All right, now we are going to have, a current go this way and come back into this junction right there. I don't know what to call that. I 2.5 maybe. Okay, because it doesn't matter which one of those I use, but it is what goes through 2.5. It's also what goes through 10, right? And then we're going to have this guy going this way. I'll call that I50. Okay, now note that I 2.5 plus I50 is going to have to add up to I0. Okay? All right, so this is like really helpful. Now what we're looking for is anything in series and is anything in parallel. Okay, and so for series, we're looking for things where the current that flows into one directly flows into the next one. And for parallel, we're looking for things that have the same voltage drops. Okay, so for series, what hopefully you can see is that whatever flows into this 2.5 has to flow into that 10. Okay, directly, there's nothing else in between them. So the 2.5 and the 10. Why won't you just write that for me, you punk? Thank you. Okay. And then we're looking for is there anything in parallel here? And it's tempting because this looks very parallel, right? It does. But notice this one's, let's use a black here, right? We're going from red over here to black. There's nothing else that goes from red to black. This one goes from red to blue, and this one goes from blue to black, but it doesn't go from red to black all in one go. So the first thing we want to do is we're going to combine these series because there's nothing in parallel at the moment. Okay, so let's go ahead and redraw this sucker. Let's see here. Okay, so we got a 10 volt. And then I'm going to go around this way. Okay, I'm going to go down here. It's going to split. Okay, this one's still here. Okay, because the ones I'm going to combine are the 2.5 and the 10. So we're going to combine those into this guy right here. Okay, let's see, like that. And then we'll come back together and we'll go around this way. We'll go that way. Okay, and so this will be delta V equals 10 volts. This is still at 50 ohms. Okay, and the nice thing is when they're in series, I'm not even going to show the work, you just add them up. So it's going to be a 12.5 ohms. Okay, now let's go ahead and let's continue to consider. Let's get our trusty dusty highlighter and let's go ahead and highlight what we know, right? So let's start with everything on the negative side of the battery. There's no ground, but we're still going to treat it like it's this one right here. Okay, so let's go here. Oh, come on, give me there. Okay, so V naught equals 0. All right, now everything on the positive side of the battery. Let's trusty dusty highlighter. Oh, take gum. Okay, we're going to use red here, right? So we're all going to get the same voltage. Everything that touches with the wire has the same voltage. Okay, and so I'll use my pen again, and we'll note that V1 equals 10 volts. Okay, thanks to the battery. All right, now this little blue voltage right here, it got squeezed out because... All right, so now let's talk about currents here, okay? So we're going to go and we're going to say, okay, well, I know that I naught is going to leave this battery. It's going to come down there and it's going to split. So it's going to be I naught, same I naught from before, right? Okay, and now we've got I naught coming back into the battery. Okay, same I naught as before. Okay, now we've still got the current splitting between these two sides. So I'm just going to keep calling it what I called it earlier. So this will be I 2.5. Let's zoom in so that I can 2.5. And this will be I 50. Okay, nothing has changed. Okay. All right, sweet. Let's see. Can we solve this sucker? Not really. I'm still looking for series and parallel here. Series and parallel. Okay. So series, we're looking for, does anything flow directly from one resistor into another? No, like there's like I 2.5 and I 50 are completely different. What about parallel? Well, we will note that for both of these, you know, they've got red or 10 volts on this side and black or gray or whatever that color is, 0 volts on that side. This one's got 10 on this side and 0 on that side, so they're in parallel. So yay! So we get to do the parallel stuff. All right. So let's combine these, and we're just going to have a single parallel. We're going to have a single resistor over here. Okay. And because this is all of them, I'm going to go ahead and call it REQ. Okay. We've got delta V equals 10 volts. Okay. And let's see. Let's go ahead and highlight in our voltages. So everything up here is 10 volts, and everything down here is 0 volts, right? So this is going to be V0 equals 0. This will be V1 equals 10 volts, okay? Now we know our single current. Oh, dadgummit. Okay, it's going to go this way, like that. Okay, and that's going to be I naught, right? It's the only possibility. Okay, now REQ, we have to figure out what that is, the equivalent resistance for the whole thing. So let's go ahead and solve that over here. REQ equals, well, these are in parallel, so we got to use the inverted formula, 1 over 50 ohms plus 1 over 12.5 ohms. Okay, and don't forget that. That's going to be the most missed thing. So REQ equals, okay, hopefully, you know, once you do a few more of these, you'll start to get a feel for what this number is, or it will be. But we will note that based on pigs, this has to be smaller than the smallest of 12.5 or 50. And so it is. All right, so there you go. We got 10 ohms, okay? So now in this particular circuit, if we solve for everything, we've got this is 10 ohms. Oh, we need I naught, don't we? Okay, so let's go ahead and get I naught. So whenever you're looking for a current, you're going to have to do delta V over R. Okay, and I naught is always delta V bat over REQ. Okay, so I naught equals, what's it, 10 volts over 10 ohms, right? So the 10 volts is here, the 10 ohms is there, and so I naught equals 1 amp. Sweet. All right, so we have now solved this version of this circuit. Okay, so we're going to use that information and we're going to go back up. Okay, let's see. So now we're up here, and oh no, I naught is 1 amp. I know this I naught is 1 amp. Okay, and let's see, what else can we solve for over here? Well, we pretty much know everything except for I 2.5 and I 50. So to get the currents, right, if we want currents, we're going to need to use voltages. So I 2.5 or 12.5. I guess we've been calling that 2.5. Let's call it 2.5. Let's keep on. Let's keep going with the same variable names. 2.5. Okay. I 50. Okay, equals delta V 50 divided by R 50. Okay, I 2.5 equals delta V 2.5 divided by the resistance. So I'm going to call that, that's the total resistance here, 12.5, R 12.5. Okay, delta V 12.5, right? This really is 12.5, but I decided to call it 2.5 early, right? So it's the same current, right? Anyway, so anyway, we'll just go back and call that I 2.5, because that's, you know, it's just what I've been calling it. I 2.5 equals, so the delta V is it's going from 10 down to 0, so it's going to be 10 volts over 12.5 ohms, and I 50 equals 10 volts. Again, it's going from 10 volts down to 0 volts divided by 50 ohms, right? So I 2.5 equals 0.8 amps, and I 50 equals 0.2 amps. Okay, we can go ahead and check our math here. We knew that these two, because they were splitting out, right? They were both splitting out from something that was coming in that was 1 amp, so they have to add to 1 amp. Oop. Come on. To 1 amp. Okay, so we feel pretty good about things. All right, so this one is now solved. We know everything in this one. Okay, sweet. All right, so let's go back over here and let's see. Here's the whole circuit up here. What do we know? Well, we know I. Well, let's see. Let's see. We know this. We know that. We know this guy. We know that guy. So all we don't know is this V2. Okay, so anytime you're looking for voltages, you have to solve for change in voltages, right? So delta V over this 2.5, right? That's how we're going to get at it. I could do delta V from 10 as well, but I'm going to do delta V of 2.5 equals I 2.5 times R 2.5. Okay, so that's going to tell me the difference in the voltage between here and here, right? And so I'll take the 10 and I'll subtract that difference to get what's going on at 2, right? Do we care about that? I don't think we do, but we don't actually care what's going on in V2, but we'll go ahead and solve for it. All right, so delta V 2.5 equals I 2.5. What was I 2.5? Oh, right here, 0.8. 0.8 amps times 2.5 ohms. Okay, delta V 2.5, so what is that? Is that 2? I think that's 2 volts. Okay. So that means we're at 10 up here. We're going to go down by 2 to get here. So this is going to be 8 volts because we went down by 2. Okay. And then just to, well, it's not even just to clarify the work. I need to get the delta V from here to here. That's one of the other things I'm asking for, right? So delta V10 equals I10, which happens to be the same as I 2.5, R10. Dadgummit. Really dadgumming the day away. So let's call this 10. Okay, delta V10 equals 0.8 amps times R10, which is 10 ohms. So delta V10 is 8 volts. Okay, so we went from 10 volts. We dropped by 2 to get here. So now we're at 8 volts. And then I'm going to drop by the remaining 8 volts to get down to here, which is going to be at 0. Okay, so I think that means we've got everything. Okay, so let's go over here and let's see. So delta V 2.5 is right here. That's 2, and delta V 10 is 8. Okay, delta V 50. I'll never solve for that, but I'm going from 10 to 0. That was actually a given in the problem. Okay, and let's see here. I 2.5. Where's I 2.5? I 2.5 is 0.8, and I 50 is 0.2. So 2.5 is 0.8 amps, and then I50 is 0.2 amps. And then I10, we'll note that these two have the same current going through them. So this is 0.8 amps, okay? So these two have the same because they're in series, right? Anyway, so that's it. That's the solutions. All right, hopefully this is helpful for you guys. And anyway, take it easy. Take care of yourselves. All right, bye.